Hey guys, are you all muted?
Oh, hi.
Hi, hi, hi.
Hi.
Okay. Well, we'll just start 8:10 or something. Just feel free to have, you know, general conversation. Also, you guys can decide who's going to live code today, right? I mean, I'm pretty sure a bunch of you haven't had a chance yet. So and and also noodle ideas for coding. We want to be using arrays, solve something interesting maybe, or yeah, we got time. We got 10 minutes, right? 10 minutes before we actually start coding. So you have to think of something you'd like to accomplish. Ideally, it should be something. I know it's hard. It's kind of hard at this stage to visualize how many lines of code it's going to be. So if I say, yeah, it's got to be simpler than, I don't know, 50 lines of code in order for us to be able to implement in class. And I only know that because I've done this kind of thing so many times. So how do I give you a good idea of the level of simplicity to look for? Yeah. Okay. All right. It should be a program that you would, if you were the driver. Yeah, I think this is a great way to do it. Okay. So think of an idea that if you were the driver, it'll take you about a half hour to implement. Okay, not more than a half hour. With guidance from the rest of us. Not like meaning that anytime you're stuck, you don't have to go off and look up resources and search the net and so on. If you're stuck, you can assume that you have an instant unblock because there's so many of us, right? So we'll just point you in the right direction. So if that is a condition, if that is a situation, you can think of something you can do in a half hour. So basically take it from an idea, even if you didn't know programming at all, through to a completed code. I know last class we didn't actually go, cover the last mile, but Turkey actually went ahead and implemented the rest of it. At least one version of it, right? It was a very interesting version. Turkey went ahead and converted the whole corpus, right? You took all of the sentences and yeah, okay, cool. That was actually pretty cool too. But what I had thought, and maybe someone else can do this, right? Maybe someone else can take this challenge on because he's done this one. Is to say when you like an 8-ball, right? Like an 8-ball, when you play the game, it's going to just select a random code, even you don't know what it is, right? It's going to select one of those random codes and then do the replacement of force with pants, or maybe make it more interesting. It doesn't have to be pants, right? It could ask you what I need to replace it by. Oh, what is your favorite thing, or what is your favorite thing of the day, right? And then it'll take that word and slot it in the place of force and turn it back to the user. So yeah, there's a infinite scope for variation, I guess, here. So you guys can feel free to knock yourselves out. And I'd be surprised if someone hasn't implemented a JavaScript version of it. You just go online and play, right? Bam, like that, to a URL. To visit a website and then say, I want to play this, force pants game, right? And then you can get to select, all right, what kind of codes do you want? Do you want Star Wars codes, or you want Game of Thrones codes, or you want, generic codes, Alfred Lord Tennyson, all right, all kinds of things you can select, play around, right? And then, what do you want to replace it by? And that should be implementable in JavaScript in less than a day, right? Maybe tie in some bells and whistles, search for free sounds here and there, and I can put it together, right, in a couple of days. I'm pretty sure there must be something like that online, because you don't even need a website. And you need a website, obviously, but it's like you buy a $199 website, right? But you don't need a server. That's what I mean. So you don't need a server. JavaScript's all static pages, right? It's just pages. If someone visits the page, the code will run, but it's not running on your server. It's running in their browser, right? So that's the beauty of JavaScript. And so yeah, so you don't have to pay for anything, like maybe 2 cents a year, right? to have something like that up. All right, if you guys should just feel free and talk, okay? So, all right, so I see some of the regulars are here, okay? Yeah, David had his camera on before and he switched it off, okay? Maximum is I have not had this camera on yet, right? Okay, all right, so anyway, I'm gonna disappear. I'm gonna go off camera, right? So,
Hi, Professor. I have
Yeah.
a question. So, what date will the quest 1 to 4 freeze?
Yeah, isn't that so you guys asked this on the Reddit too, right?
Yeah.
And I replied to it, right? So technically the free state is supposed to be yesterday, right?
Oh, yesterday?
It was supposed to be yesterday, but if you guys if enough of you don't want it to be yesterday, I can make it next Monday.
I thought it was the Sunday before the midterm.
That's basically is Monday after I work. Oh, you thought it was Sunday before the midterm?
Yeah, because that's what you said last week. You said last Tuesday that was the free state. You like.
Oh wow. Okay, so I gotta fix the syllabus, right? Because if the syllabus, I think the syllabus says something wrong then. What does the syllabus say? Week 5?
Nah, you definitely said you were gonna have it right before our exam, though. I definitely remember.
No. I remember that. I remember I said that in the class. Yes, but I'm pretty sure. Hey, does someone have a copy of the syllabus?
Last Tuesday, you said it.
Tuesday. I agree, Elizabeth. I did say it was a Sunday. That doesn't matter to me, honestly, right? But I'm just confused. If someone has a syllabus handy, just let me know if the syllabus is wrong, because I think in the syllabus I might have said week 5, right? Or whatever it is. It doesn't matter.
Yeah, but maybe like the end of week 5.
Yeah. Don't worry. So Monday. That means Monday, right? Next Monday.
Syllabus,
next week is
the syllabus says it's supposed to freeze date for quests 1 through 4 on week 5.
Yeah, see, that's what I thought. I got to fix that then. I gotta fix that. Why did the reason I put it there was I was thinking in my mind when I wrote the syllabus that you guys need 1 week of not questing to prepare for your midterm. So let me make sure that all is done 1 week before, and then I must have done the 6 minus 5 instead of saying because your midterm is at the end of week 6, right? It's on a Thursday. So you don't have to. You can have submit everything on Monday, and then you still have 4 days not having to do
someone note.
So the quests are all freeze till Sunday this week. Is that correct?
Yeah, that's basically Monday when when I wake up, I'll try and freeze the file.
Okay.
And so same note, if the other freeze date is wrong on the syllabus, it's
I'll fix it. I'll fix it later today.
Okay.
Right. But if you have a whole copy of syllabus, it'll still say week 5.
All right.
All right. So you guys want me to take off screen for about 5 minutes or so? You can talk and come up with ideas, do what you want, and then we can start class at 8:15. Yeah, and then we'll just pick up an idea. One of you can code. How about well, assuming nobody else joins us in the meanwhile, I think let's see, Yenyu hasn't gone, Maxim hasn't gone. I don't know, David, maybe you went on the very first class. I forgot. Otherwise, you guys can just feel free to, draw straws or something like that. Okay. So, I'll be back in like 5 minutes. I'm just going to be here. Okay. I'll be here. And call out to me if there's something. Because I'm trying to think of, let me try and think of something interesting. Okay. In 5 minutes, I'll just go off screen. I'll try and think of an idea. If you guys haven't got an interesting idea, we need a good backup. Okay. All right. All right. See you guys soon.
I have an idea. So have you guys tried to recall, like after making a function or a method, to recall it inside the method again?
A recursive?
Yeah, like when you have a method and you just recall it again inside the method, because one of the quests in the last one, like that could have been a nicer trick to do it.
The quest 4, I cannot remember which one. Yeah, I
forgot which one too.
Recursion, yeah.
Yeah, I'm still working on that one. I've done like 3 of them so far, the mini quests, and then I have to finish the rest. So when he said that it was due, I was like, wait, what? Like, oh.
Yeah, but this methodology can make it simpler.
Yeah.
So you don't need to add more lines. You can just like do it inside of itself. Kind of want to try it. I mean, can we try these kind of methods in our quests or?
I think we can. I just passed it.
Yeah.
Yeah, maybe don't. Yeah, just use like different code or something, like not related. It should be fine.
Let's see. Oh, it's the GCD one.
Yep, that's the one I think. Yep, it
Yeah.
is.
Should we try like similar thing?
Yeah, I think that will be like a good trick to learn. We should
Yeah.
do something like that. Let me see if there is something like that other than the GACD, because
we could use recursion to get the factorial of a number, or the n Fibonacci number.
we can do a factorial of a number, because I think one of the questions is going to be the Fibonacci and no requests.
Oh yeah.
Have any of you guys heard of Rosalind? Yeah, Rosalind's pretty good. It's got a few problems, and normally it asks you to do it in Python. I've done a few in Python. Have never done any of these in C++ though, and I think this first one's pretty easy. What do you guys think?
Is there a way we can do a recursion in this?
Oh, is this week recursion?
Not really.
No.
Okay.
We're just chatting.
Yeah.
This seems a little too simple for recursion. It's going to give you a DNA sequence, and then you're just going to count each of the different letters and how many times they occur.
We can do it use for.
Yeah, this is just a pretty basic for loop kind of problem, but let's see. This one might use, well, no, this one's pretty straightforward as well. This one might actually be okay with recursion, although this one's more on the complicated side, in my opinion. I don't know if you're seeing. This one's kind of like a binomial distribution. Or wait. Yeah, it's sort of like currents relation. Some of the definitions here are useful, but I think, at least in terms of what would be functionally somewhat useful while also being somewhat easy to do in 30 minutes, would be this one. Since you've got, an input data set that you'd get from the website, and you would copy, and then you'd paste it into the input for your program. And then your output would be like this, and you just loop on your string input. Just an option.
All right, there's quietness here. So anyway, I was trying to, I don't know, does anyone know how this pinning thing works in Zoom?
So
Yeah, if you
pin
want to
should
place
put
people in
the
certain,
person's video at the very top left of your screen. If it's in gallery view,
where the badge icon?
if you right click on one of the video feeds from a person and you pin that, it should put it at the top left or make it like the first window that you see.
I see. Okay. Well, I'll try and figure this out. It's a bit distracting when things are jumping around all the time. And then if you want to fix, like in class, and I'm trying to see if I can, if we could make it as much in like in real class as possible, right? Because students tend to pick certain places and sit there. Although, surprisingly, I used to, back when I was doing face-to-face for the first few classes, I used to use that information to help me remember student names, right? So I would always say to myself, okay, for the first few classes, oh yeah, the person who's sitting in, left in matrix position 2,7 is Derek or something like that, right? But then it's only after week 3 then I can associate the names of the faces. But here in Zoom, for instance, for some reason, it just happens on day 1, right? After the first class, I pretty much know most of you by first name. But still, I'd like to not have you shuffle around. And so if I can, have you fixed, maybe it depends on the order in which you order. Maybe Zoom has to figure it out. It usually has to have this alphabetical ordering or option or something like that.
Yeah, I feel like the order that you see people in the gallery view is dependent on when they join the meeting.
Yeah. But I think I'm at least I'm happy that you guys are not, snapping around while you're talking, right? That would be really freaky. All right. So anyway, I heard some words being tossed around when I was, playing with the pinning. Oh yeah. So you want to try recursion? Well, we could try that. Ideally, I'd like to keep recursion out of CS2A altogether, right? Because you don't really have to do recursion in any of these. In Fibonacci, for example, in week 4, it's possible to do it with recursion, and it's really, really tempting, right? And I think that's the reason I put it there, because you need to be able to say, lead us not into temptation, that kind of thing. It's right there, it's dangling in front of you. It says, oh, I'm, recurse, I'm here, do something. But, if you recurse, you're basically stuck there, because, Fibonacci is one of those bad kinds of recursion. Right, it screams out to make you do a recursive implementation. You can try it out today, right? You can try it. No, actually, we shouldn't, right? Because it's part of the class, and you should try it out in your own time, and then be, by flummoxed by, why the hell is it not terminating? And then you can actually work out. We'll look at all of this in the last class. Okay, we'll actually talk about recursion in week 11. Right, week 11, we'll talk about recursion. In fact, we'll come back to Fibonacci, and then maybe we can use that as an excuse to talk about dynamic programming and, segue into memoization, dynamic programming, and things like that. We usually talk about something like that in the last couple of lectures. It's really not part of CS2A. It's enough to know what recursion is and what things do. We can try a couple of examples today. Right? Otherwise, I'll try, we'll do simple programs, because this week we're technically supposed to be talking about functions, not methods, functions, free floating functions. What functions are, at any time, if you want, I can dive into the detail about what actually happens when a function is called, right? So, the parameters, where do the parameters go? What does the CPU do, right? What does the CPU do? And what's the difference between, functions and macros? There's so many things you can talk about it, right? You can do an entire course just on functions, right? 12 lectures on functions. So it just depends on where, what aspect of a function appeals to you. Right, and then you can start going into more detail in that angle, right? Is it the parameter passing, or is it, continuation style or something like that? All kinds of crazy things to do with functions you can start thinking about. Right. So anyway, so that's what we'll do then. In today, if when someone starts coding, I was actually looking at 4 people who didn't have their cameras on. I think Srikaran came on briefly. So Isaiah hasn't switched on his camera. Maxim and Rishabh. All right. So we don't know if you're here. All right. And I think Maxim hasn't taken the screen either. Hey, Chanyi, you have a question?
Yeah, would it be possible for us to run through how to simplify the number? Because I saw Haoyuan and Turkey said about the how to get rid of the trailing zeros, but I tried myself and I still cannot.
Well, how about this? How about this? Okay, how about this?
Oh yeah,
Why don't you try
I
now?
know how to do this. Yeah.
Why don't we do it live? Why don't you try live? Chanyi, is that okay? You just try live. We'll fix it all together. Yeah, or we'll try it, or say what you want to do, and then we'll just implement it together. How about that?
Yeah. So do you want me to
open up an editor? You haven't. It's been a while anyway since you took the screen anyway, right?
Yeah.
All right. Take the screen. Open up an editor. Say what you want to do. We'll code it up. Maybe 5 or 10 minutes. Okay. Which means we can still come back to this game or whatever it is that we want to do, right? But we'll wrap up what you want to do in 5 or 10 minutes. That way you'll have an idea of actually doing it and getting it to work all from start to finish. You want to do it here, or I thought you had VS Code. That doesn't matter. I mean, yeah, online C++ compiler is fine. Yeah, Replete. I think what we do G++ GDB online GDB.com. I think Jinghang.
C++ shell, right?
No, I know what is that Jinghang use last class.
Yeah, I know it's the first one I use. So
I once use
yeah, this one.
exactly this one.
Yeah, this one. Although
I do use the Xcode, but it has all my quest answers, so I think I cannot post that.
Yeah, don't worry. This is fine.
Okay.
By the way, Xcode, you'll find how you can keep all your projects closed, right? You can only open the ones that you want.
Can I?
Yeah. So if you have like 10 projects, because once right now maybe you've started Xcode using Xcode for a couple of months, right? Yeah, maybe next year you'll have 50 or 60 projects at least, right? Some random projects, some stuff that you've even forgotten about. They're all there. You can't have all of them open. So what you'll do is just close off all these projects and only have one active project at any time, or maybe 2 max. You find out these things eventually, but you should be able to share. But don't worry about it. Let's do it this way. All right, what do you want to do?
So this is the code I have for the GP.
Mm-hmm.
And if I run the answer, it will give me a number that is 4.0000000. And I want to get 4 instead of having all that zeros.
Oh, I see. So Turkey was trying to help you with. Yeah.
The question is, you should not use the toString method.
Yeah. That's what Turkey was saying, I think. If I interpreted your answer correctly, Turkey, you were saying that use that convert OStream, OF stream or something like that. I keep forgetting. We've got to look it up.
It's the SS stream library. You use the O string stream, and you assign it to to the buffer that you choose the name of. Then you use that OS as your input. And what it does, it takes the console output and use it as an input. So actually take rid of the trailing zeros.
So I think the easiest way is to look up the Lucifer's the module 3, I think.
Module 3, you mean the textbook?
No. Hey, Haoyan, just put the link in chat.
Oh, okay, sure.
Yeah.
Give me 1 second.
He's talking about Michael Losef has a module on exactly this, right? One link.
Yeah.
Oh yeah, all of it. One page. You don't even have to leave the page. Has all the examples well laid out, right? And you just copy and paste, it'll run.
Okay. Since I just saw Turkey upload an introduction website about.
Yeah. He shared a very useful link.
But I still cannot understand
Yeah.
because I know the string is very easy to understand. Just transfer the type of the array into a string, but the SS string, that thing.
All right.
SS stream.
Yeah. Don't use toString because you don't really have much control over how toString formats the integer, right? So, what you tend to do is what Turkey was saying is, hey Turkey, do you want to walk Tianyi through this, or do you want?
Oh yeah, I can do that.
Thank you.
So first of all, just include the SS stream on the top as the library. And go down to where the loop is. Because what you want to do, the SS stream, when you declare it, if it's outside the loop, it will just keep adding to the stream and it won't clear up the cache in it. So the first thing we do is type in OS string, like O string stream.
You mean here?
Under the 4.
Under the 4?
Yeah.
Hey, quick question. Would we need to include the string library as well for this at the top?
I don't think we need it. I never used the string library part.
Okay, cool.
Like this?
Yeah, O string stream. So this is declaring a stream, like the same way you declare an integer or like a string. You're declaring a stream right now. Name it whatever. So let's say name it OS.
Like this, or
space OS. Yep. Okay. And now you use OS as your input. So below OS, then 2 arrows to the left. Yep. And now you can assign anything to it. So if you have any calculation that you do, it will go there as an OS. So that number will go there as a, what do you call it? Not an integer, the other one that we're dealing with, a double.
A double.
Yeah, so do the math there, or put any double value there. So let's say, where's your double? See the GP that you have? No, that's actually not the double there. Oh, okay. So assign the function below a star list RI to the OS instead of assigning it to FIM.
Like this?
Yep, and remove the double. You don't need to have the double declaration there. So move that one down. Great. So now your OS, which is the stream, will have the value of that calculation as a double. And what you do is you turn that value of the stream to a string. So now clear the toString in front of JP under the if function.
You mean
yep.
This too?
No, just the toString part. Just delete the toString part.
toString.
Yep. So under the SS stream library, the way to declare that stream as a string, you just say the name of the stream dot str. So after the plus for the GP string, type in os dot str and double close. Here you go. So what happens now? The double value turns to a string. It takes get rid of all the trailing 0, the same way that shows in console, and assign it to the string. Do the same thing at the bottom. And that should remove all the zeros.
I see. Would you mind if I have a try?
Yeah, but don't you need to put like the list RI as a parameter into pass it into the os.string, or is it by itself?
Well, you're doing the math equation inside. Like imagine the OS stream. What it is just a buffer value that holds whatever value, attach it to it, and show it as it shows in the console without taking the full data information, if you know what I mean.
Oh,
Because
okay,
a double
okay,
have a lot
that
of
makes
zero when it comes to the size.
Oh, okay, okay, that makes sense. Thank you.
Okay.
Do you want to run it, Chanji? Where is the output? Didn't we have this problem with Jinghang also? Because as something we were struggling to look for something and we couldn't find it here. Oh, there it is. There it is. There it is.
Oh, got it. Thank you, Turkey. I think I understand now.
Thank you so much, Turkey. That was fantastic. Yeah. So essentially, yeah, it's this way you have more control over exactly the formatting that you desire. So everything you can do now to format a number sent to a stream, and I think, and I'll leave you to Google it and find out on your own. It's called the, you can basically say output formatting in C++ via iOS, right? So there's a whole bunch of functions available to you that let you set very, very specific things. Like I want to set the width of the number to 15. I want to set the precision to 7, right? I want to have this many leading zeros. I want it to be in hexadecimal. So you can tell you, so these are all signals. You can see these are, right? These are not printable things. So anything you send to a stream, here's the cool thing, right? Because the C out is not the console, right? C out is not the console. Is a very important subtlety, right? We always think send it to the console, send it to the console, send it to the console. No. C out is not the console. C out is the person that knows how to talk to the console. Therefore, you can send C out a whole lot more than you would normally send the console. So it just needs, that's all meta information, right? So that is stuff that C out will understand, interpret correctly, but not necessarily send to the screen. So one such information is that's called control characters, right? Control characters. So control characters are not sent to the screen. They're just used to control how cout behaves. So so you can tell, oh, here's send hello, send world, send all these strings. Now send a number. Oh, there's a floating point number coming up, but that number should be output in this particular way, right? 4 decimals and so on and so forth. Here's a control sequence for it. Right, and it's not a fun. You don't have to construct the control sequence. That's what I'm saying, right? So there are functions that will say, you can actually say, I want this, and it will automatically, the C++ the library manufactures what needs to be sent to cout, so that when cout later receives that floating point number, it knows that, okay, this floating point number, even though it's like this much, it needs to be truncated and to that particular style before being sent to the console. Okay, so cout and cin are not your, although we've been accustomed, sometimes by now to treat them as the keyboard and the screen. Now they are just intermediaries, so you can send them and read from them a whole lot more. So that's why we didn't go into great detail into formatting itself. And then I just but you do need to know about formatting. But we can talk, till kingdom come, right? About formatting and so we said, since we need to know, but there's so much in there. It's part of the quest or your homework rather than part of a class. Okay, but for formatting itself, there's no magic to it. You can just look it up, and it's basically just a sequence of things you tell the compiler to structure your output in a particular way. And it's just it's my mini language. Think of it as a mini language, right? You're right. We're trying to learn C++, and this is like a small tip of C++. So you can easily pick this up. All right. So if you don't have any further questions on that front, we'll try and take the screen, and rather than do something with a we're going to experiment, right? So that's what I was thinking. We'll just experiment with a bunch because we're talking about functions and parameters. We'll just write a bunch of functions, call those functions with parameters, All right, and then really what we want to try and understand is that C++ gives us very nice feature, right? A parameter can be sent actually or a copy of it, right? So two different ways in which you can pass a parameter in C++. Very few other languages give you that power, right? Right off the bat, you can actually get that power in other ways, hide it inside an object and so on. But C++, that power is actually raw. You can actually see it. So when you pass something to something else, you can say, right? And so there's all these nuances around how parameters are passed from a function to another function. So we can talk about that. And we can also talk about, what's actually going on. What's going on? How does the function get the parameter? Where is it, right? So we can do that. So yeah, and then it'll also, are we supposed to do stacks? Yeah, we'll do stacks towards the end of the quarter. Yeah, but it'll bring up the idea. So there's something called a stack. A stack is basically what is called a last in, first out data structure, LIFO, right? People always say stack or LIFO and things like that. Last in, first out, meaning it's a stack of plates, right? Stack of plates. You can't take the bottom plate or the middle plate out. You always, everything that the top one is the last one that went on, right? So the way a stack is assembled is basically the last thing to go on top has to go off first, right? So until that's gone, the one underneath cannot go. So it's like that. Okay, so and you can duplicate that in an array, right? So add numbers, okay, into an array. But say I'm going to sacrifice the entire power of the array, because the power of an array is that you can basically just go, even if you have an array of 1 billion items, right? 1 billion items big, the power of the array is that you can go to any damn random item, right? For the same cost, right? It's going to take you the same amount of time to go to element number 23 as to 1 billion minus 23, right? Same time, bam, 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 right? Like that. So that is the power of the array. Arrays, vectors, and things like that. Yeah, and we learn that, right, as we get into CS2A and 2B and 2C especially. But with stacks, what we're trying to do is really, it is C++, right? We're saying, well, the array is so powerful that if I had a raw array at my disposal, I could do a lot of things to it that I don't want to do, right? So I want to take the sheer power of the array and hide it away so that I cannot see the entire array, right? I can only see the head of the array, the top of the array, right? Most the power of the array is basically hidden away. I can only see the top, right? So that actually has a very good use now for us, because since we can only see the top, right? Only what's on the top of the array can be visible to us, right? So if I push something on top of the array, what's on top has now gone below the top. I can't see it anymore, right? So here is a fantastic situation, right? It really is a fantastic situation where we have given up power, which is available to us, right? The entire array is available to us, but we're saying, I don't want that power. I want a very specific form of that power in which most of the power has been shaved away, right? And I'm taking the sliver because that is exactly what I want. And that will save me from the headache of having to look at the entire array. Because if I look at the entire array, I got more things to worry about, right? So the fewer things you have to worry about, the better it is for you. So you're saying, I don't want the entire array, so I just give me the top element. So that is basically a stack, right? And if you think about the stack of plates, right? So if you gave someone, right, you got to load these 100,000 plates into the dishwasher, okay? They're gonna say, no, that's too much, right? But you say, you show them the top plate and say, well, all you need to do is just keep popping off the top and load these dishwashers until the stack is empty, right? So whether it's 100,000 or 1 million plates, they're gonna keep doing that, right? So, right, so so you see the power of the stack, right? It's the power of the stack. So you can only see the top, you cannot see anything underneath, right? So that's an example of how you actually gain power by giving power, right? You've given more power, but you actually gain power because why is it that you gain power, right? So here's the interesting thing, right? I think it is more, I don't even know if it's computer science, right? But it has to gel, right? It has to be consistent. The energy cannot be created out of thin, right? Right? So where is the gain? We're giving things away, right? So we're giving away the power of the array, and yet we think that giving away has actually made us stronger, given us, right? Why is that? So here's my hypothesis, and we can test it, right? So what we've done is that, what are we giving away? We're giving away things that can be done by a machine, right? By giving away things that can be done by an automaton, by a machine, we are thereby freeing up our mind to do more interesting things that are important to us, right? So our mind is now able to focus on things that cannot be done by a machine. And therefore, we've actually gained cycles. We've gained cycles in looking at the problem by giving away all, stupid things that we thought that we were controlling. Well, we're controlling like a machine, right? Whether we controlled it or not, it doesn't matter to us, but it just gave us this feeling of control, right? So we can just give it away. Those things don't matter. And then we are able to focus on what really matters. And that's what really gives us this feeling of gain. And I think that's what's going on here, is in the whole of C++. Though, even to talk about visual scripting languages, right? So talk about, I'm pretty sure, when Apple or Google, they launch these, virtual development environments or glasses programming and things like that. They'll have something like, Unreal blueprints, and where you have visual programming, right? So the visual programming is really the next level. Every C++ class, has, functions and getters and setters. You don't have to type them in, right? You can basically have blocks like, Tom Cruise does in that, there's a Spielberg film, right? So rearranging blocks, just be visual programming, right? Drawing arrows and, connecting things. Most of the logic can be done like that. Very, very subtle ones, they have to, go into the wires and tweak things, right? So I think a lot of these things will start gelling together eventually. And you won't even be able to see, what's actually, unless you're really interested, right? You don't have to dive into the details to see all these details. And I think we're in a anyway, I don't know how we got started talking about this, but so anyone who wants to go take the screen, you should basically.
Professor, can I volunteer?
Who is this, by the way?
Chris.
Chris, yes, thank you, Chris. But hang on just a sec, okay? I haven't seen Maxim take the screen. I know David. Hey, hi, David. I was looking at your office. Is it your office or your home?
Yeah, this is my living room, but I'm also working right now, so sometimes I jump in and out of meetings. But
I see.
Try to keep my
I
camera
was
off,
looking
at
at it,
least.
and it looks really fancy. It looks like an office, and it's really cool. Yeah.
Yeah, it's this is the entirety of the house, so it's not the basement unit. So it's not too fancy.
Funny, very nice. All right. So anyway, have you taken the screen? Did you go the very first time, David?
I shared, I think on like week 2.
Okay, so now you went. How are you on? You went too, right? You went too. How are you on? I don't know.
Yeah,
I went. Yeah, you went. Yeah,
I went.
You went? Okay, so I think Isaiah's gone. Maxim is the only person who hasn't gone. Okay, Yenyu, where's Yenyu? He was here. Am I only looking at the first screen? Yeah, okay, yeah. So that's what I mean, right? So you were here, and then you're here. All right. So already the first class is even harder, right? Later classes, I can tell you've moved, right? So first class, there's just people, right? And people jumping around, and the names are not always visible, so it's hard. Okay, Yen, you haven't gone, yes?
I went on the second week.
You did go.
Yeah.
So everybody, so Maxim is the only person.
No,
So,
I did. No, I went really early on, like the Avogadro's number
all right,
one.
Good. All right. Oh, yeah, you haven't got your camera switched on for some reason, but I can hear you. That's fine. That's fine. Okay. Okay. Ray, you did go. Oh, Chris, you should just take the screen. Okay. You take the screen. Just remember to go a little slower, because I think there are students, unless the other students, okay, they say, okay, go faster. That's fine. We want to be very careful. We have time. Okay. We have time. We have this entire class. We have time. We just want to make sure we don't lose anyone. Okay. So, all right, thanks. All right.
So what are we doing again?
Just
were we doing the stack or? No,
we're not going to touch stack enough.
Oh, okay.
So what we're going to do is really from main, we're just going to create a bunch of functions And from main, we're going to call these functions, okay? And then all we're going to try and do is basically in main, we're going to try and change, we're going to try and change these things. Everything is going to be under 20 lines, okay? Under 20 lines, and we're going to keep changing things here and there. And before we run it, after the change, we're going to say, what's going to happen? What's going to happen? Someone will take a guess and say, this is what's going to happen. This is what's going to happen, okay? And then we'll run it and see if that's what happened. And then, you know, basically just points for discussion.
Okay.
All right, let me see. I want to increase the font size, or where are my dollar glasses? Okay. I will actually increase the gallery size first. Okay, so I get more of you here. I think that's all. Okay. 4 times 16. Oh, that's too small font for me. Hang on.
Yeah, I increased it a little bit.
Yeah, actually increase the font size a bit more, so I can still get all of you and get enough results. Yeah, Elizabeth, just 1 second. Okay. Hey, can you increase the font size a bit more, please, Chris? One more time. Okay, I think that's fine. That's fine. Okay. All right, I got all of you on screen also. That's great. Hey, Elizabeth, you had a question.
I just want to say that usually I I turn off my camera to eat breakfast. Because I go to work immediately after. So that's kind of, maybe I come in and out like of the camera. And that's why I just don't want to eat on camera.
No. Yeah, in fact, you know, when I was off, I was thinking that many of you are actually attending class from work, because I saw there was a microwave or something behind you, and I thought you'd stepped into the kitchen and you're doing a class from there. And then I thought that David was in his office also, and then I didn't know if I can just force you guys to just volunteer just like that, you know. Yeah, that's fine. Don't worry about it. Okay. I know all of you are interactive, right? And today, as you know, I'm struggling to find people who haven't taken the screen and driven, right? So that's fantastic. That's the way it should be. You know, I mean, programming should all be like a boot camp, right? Everybody's just diving in, trying to say, hey, I want to try and do this, right? So summer camp. And I think that's the only way. Because, you know, people always say, learn this in 20 days, 30 days, 10 weeks. It is not like that at all. It takes many years. All right. And the sooner you do it, the better. But the goal should not be, I'm going to be a programmer after 20 years. No, or after 5 years, or after, no, that's not what we're shooting for. We're just doing it because we love it. And because we love it, we start getting better and better. And after 10 years, you can just look back, right? And all of this is going to be on YouTube, right? So you can come back and look at this and say, wow, that was me 10 years ago, right? That was me starting out on C++, and look, and this is what I've just launched today, right? And all over the world. And you can compare, right? And you can think back. You know, most of the time we can just remember, right? You can play it back in your head, it's higher fidelity, or you can embellish it the way you want, okay? But it is so cool. I don't know how we got started talking about it. All right, so we're going to just do a bunch of functions. So let's just do, I don't know, shall we do we want a function that uses arrays. All right, let's do this, okay? Let's say find average, right? Yeah, find average. I know. Let's just take 5 numbers and find the average. All right, we're going to do this in a bunch of different ways. Find average is so boring, right? It's just an average function, right? Is there something more interesting than find average? Otherwise, we'll do find average, okay? Find average or find mean. Let's say, can we, or given 5 people, given 5. All right, how about all right, so I'm gonna reserve this for Thursday. Okay, so if on Thursday, if nobody has an idea, this is what we'll do, right? We're just gonna create a random sentence, right? We're just gonna create a random sentence from a random verb, a random noun, a random pronoun, right? And we're just going to assemble them. So you're just going to be given, and you say, give me a random sentence, it's going to give you a completely random sentence, right? I'm pretty sure, because in a later quest, I think in quest number 6 or 7, I think it's 6, you're going to create a random name, right? We used to do that in class too, right? You're going to create a random name, a pronounceable name. Out of using random characters. You're going to do that in one of the quests, but we won't do that in class. We'll create a random sentence. We'll do that next class, right? Well, next class we'll create a random sentence, and we can do that today too. What time is it now, by the way? What time is it now? Oh, it's 8. Yeah, we got a whole hour. Maybe we'll even get to do it today. We'll start off with some very simple functions. Okay, I just want to give you some demos. Maybe it'll take about 15 minutes. All right, and then we'll go. We'll just go with find mean. Okay, so say int find mean. Right, just type int find mean. Int find mean. And then let's say and above find mean, just say above. Let's put a comment saying find the mean of 5 integers passed in as parameters. Find and return, right? Or return the mean, right? At the end, you're going to say return the mean. And those are things we're going to play with, because there are many ways in which you can call functions. Sometimes you get an explicit return. Sometimes you get, a return that's put in a box for us. We'll look at all those things, okay? And at the end, also, I'll show you what happens when we have uncontrolled recursion, right? So we were talking about this, and Turkey also brought this up, right? And we'll try something that does recursion, and we'll try and see what happens when we are not careful with recursion, right? So that's the reason we don't talk about recursion now. Right. So what Chris is doing now, and also let's insert a blank line between the two functions. So what Chris is doing now is that he's got 2 functions. One is main, right? Main is our function that is going to invoke all these other worker functions that we define, right? So find mean is a global function out there we've defined, and it takes 5 integers. You got to, every time you call find, you've got to give it 5 integers, right? 5 A, B, C, D, E. Well,
there's 6.
Yeah, there's 6. Yeah, I changed it to 6. Yeah, that's fine. That's fine. I know 5 is good enough. That's fine. Just leave it at E. Right. And in the int mean, you say mean equals. All right. In fact, on the same line, you can even do this on the same line, right? Int mean space equals. Right, because you don't have to have it on a separate line. So A plus B plus C plus D plus E. Right, at the whole thing, and then fixed spaces, and the whole thing in parentheses. No, now you can't do that, right? Because then it'll do E, because division always PEMDAS, right? Division takes precedence over addition, and right, so it's going to do the division first, and it'll do E over 5, right, and add it to A, B, C, D, right? So we want A plus B plus C plus D plus E within parentheses. And the whole thing divided not by 5, right? Because if you do 5, it's going to do integer division. So what we want to do is, rather than make find mean return an integer, we want find mean to return a floating point number, right? Because the mean 1 plus 1 is going to be, the mean of 1 plus 1 plus 1 is 1.5, right? So 1 plus 1 plus 1 divided by 2 is 1.5. So we don't want to truncate the 0.5. So you say float, and then float mean equals. But if you do divide by 5, here's the thing. Put 2 spaces. One space around the for the divide sign. 1 space on each side. Right now, if you do divide, so here's the funny thing that's going to happen, right? So as PEMDAS, you would have discovered this. The left-hand side of the equals, because equals is also an operator. Here's the really strange thing about C, not strange thing, right? It's the thing that needs getting used to, is that the equal sign, right, is also an operator, just like any other operator. You can even override it. You can make the equals mean something completely different, because C++ gives you the power to define the meaning of every single operator. Now, if you don't define the meaning of these operators, C++ has sensible default meanings for all of these operators. But what C++ says is that, this is what I do. It's completely transparent, right? Unlike many other languages, see, completely transparent. It says, this is what it is. This is what the assembler equivalent is, right? This is what I'm going to do. If you give me if you give me an equals operator, that's what the equals operator is going to do. This is a bunch of assembly, right? It's an operator just like any other. And if you want to change it, this is the bunch of instructions that I use for equals. If you go and change these instructions, equals is going to do something else, right? Other than what it's supposed to do. So all of that is possible. Eventually, you will be doing all that. By the time you get to CS2B, you're going to be doing all this, right? Where are we going now? So the equals is also an operator, which basically means that entire expression A equals B, right? Let me get this off, right? Because with this, some things are harder to focus, and only the font is easier to focus, right? Actually, I can still read it, I think. Yeah, right. So as I was saying, because it's an operator. Every operator in C++, when you do these things, they return a value. So this A equals B is an expression which evaluates to a value. Just like, you know, if let's take a better example, A equals B plus C, right? A equals B plus C. What are the expressions here? People might say, well, you know, B plus C is an expression because it's sum of two terms, right? B plus, so, and it's in A is an expression, a term, right? So take that expression, evaluate it, assign it to this term, right? A equals B plus C. But actually there are more expressions here. A equals B plus C itself is an expression, right? A equals B plus C is the same as, you know, A equals B is an expression too. In C++, everything is an expression because that evaluates to a value. That's why you can say later on in C++, you can actually say A equals B equals C equals 1, right? You can actually say that right here in this function, right? Right at the top, you can say, you know, on main, yeah, right.
On main.
Yeah, you can basically say, we're just in a comment, you're going to delete this line, right? You can, this is a valid C++ statement. A equals B equals C equals D equals 1, right? So assuming all these variables exist, right? Yeah. So
A equals B equals C.
A equals C equals 1. Yeah, C equals 1. That is a valid C++ statement. You will actually see that being used in many C++ programs, and there's no reason to be confused there. All that means is that is the entire thing is an expression which is composed of other expressions. What are all the expressions in there? Take the very first expression. B equals 1 is, you know, or is it C equals 1 is the very first expression, right hand side, right? That needs to be evaluated. C equals 1, we'll take the 1, assign it to the C, evaluate to a 1. So C equals 1 is an expression which evaluates to 1. So take away C plus 1, C equals 1 and replace by 1. What do you get? A equals B equals 1 now because C equals 1 has been replaced by 1, right? So A equals B equals 1. That is itself an expression. Where is the expression in there? B equals 1 is a sub-expression. Are you guys following me, right? So it's a little hard to stay in step with C++ here because there's so many things happening on just one line, right? You say A equals B equals C, right? So many things happening because there are multiple expressions. It's all cascading, right? Evaluate the rightmost one, right? Replace it. Next one, next one, next one. So all of those happen, so all telescopes, and all of those variables get assigned a value 1, right? And this pattern is now common in many languages now. I'm pretty sure it's there in Java, but I don't know if it's there in Python and other languages, but this is a very common pattern, right? So assigning multiple variables on one line also helps programmers to say that, you know, because, you know, it's not, when you say A equals 1, B equals 1, or even saying there is a difference between programmers, right? So programmers that are completely in tune, right? We're talking about programmers who've been programming together for many years, right? So they know. So they know when one programmer reads another programmer's program, right? And they see A equals 1 and B equals 1 in 2 different lines, right? In a different context, they see A equals B equals 1. The difference for the compiler, they're exactly the same, but the programmers know. Right? This person knows why that person made those 2 variables go on 2 different lines, because they know the default behavior of a programmer is, you know, or this programmer that they're used to is always doing. So those kinds, that kind of meta information will start percolating into your programs. As in when you program, your style and everything starts, right? And then the people that you work with, that's why, you know, in programming, it's good to be part of a community. Right? Because if you're part of a community, you get to know these things with all these other programmers, right? So you can learn, and without even, so that's what you say in a transaction analysis, right? So 50% of the program is in the code, right? For many experienced programmers, just the way the code is structured is also meta information, right? They know from that, right? So when you look at, you know, maybe an Unreal project, right? How much of and you look at it from a certain developer, you know, and you know, right? They put a lot of this in the blueprint and this much of in C++, all these things, right? So you look at these things, all of that is also information, although it's all, at the end of the day, it's all the same, right? They're all CPU instructions, but, you know, everything boils down to how easy we make it for ourselves to program. That's what it is, right? And we make it easy for ourselves to program by looking at other people and following conventions as much as possible, so that, you know, we don't have to waste time and in figuring out things, right? So getting used to it. So getting used to the style of the community is, in fact, part and parcel of learning a language, right? Just learning a language and syntax from the book, you know, buy the Structure book, or, you know, or the C++ grammar from the standards committee, and learn it inside out, doesn't teach you anything at all. Well, it teaches you something, unless you're like, you know, you can code everything like von Neumann in ones and zeros, right? But really a huge part of any language is really interacting with the community. That's why, you know, communities like Stack Overflow and all these other places where people code together in groups and share code, you know, GitHub, you know, all these open source initiatives, they're very useful for, you know, programmers. because they raise, they make it easier for you to program, not just by sharing code, just by picking up meta programming. Because meta programming is a huge part of the skill of programming, and you pick that up by programming with others. Because otherwise, it's hard. It's hard, and people will say, we will blame it unfairly on programming when the problem has already been solved in many cases, and you just don't know. I'm sorry, that was a huge digression to get into, right? So what's going on is that that expression, we started on line number 10, you can get rid of that comment. Thank you very much, Chris. All right, yeah. Yeah. All right, so we can go back to so that float mean equals, right? That entire thing is an expression. However, it does it from, what is it? Mean equals something, right? That's an expression. I need to evaluate that expression first. Before it evaluates that expression, it does not know what the type of whatever it is going to assign it to. Yeah, I need to calculate this and then put it there. So on the right-hand side, it looks, and everything is an integer, right? This is your lab number 2. I think it's question number 2, right? So numeric and expressions, everything is an integer. So when it calculates the average, it's also going to truncate the floating point number. If it ends up with 1.5, it is not going to return 1.5. It's just going to have 1 in there because a 0.5 will be discarded. Does that make sense? So in order to avoid that, what we do is basically change the 5 to a 5.0, which hints to the compiler saying that this division should be performed using a completely different algorithm, right? For us, for humans, division is one algorithm, right? Take one quantity and divide by the other. But the CPU does 2 different things. If it's integer division, it does it in a different way than it is floating point division, right? Yeah, Chanyi?
So if we put 5.0, that means 1 decimal place, or
No, it doesn't matter. In fact, you get rid of the 0.0 and just say point. Hey, Chris, just say point, 5 point. That's enough. It's just a hint to the compiler. So saying that one of the things that you're working with is a floating point number. Anything, if you have a point, it's a floating point number. In C++, a point means floating point number.
I see.
Right? Actually, point means double precision number, right? In fact, 5 point is actually double. It's double, meaning it's not only a floating point number, it's a floating point number that is stored in 8 bytes, not 4 bytes. If just float by itself is just 4 bytes, right? Double precision float is double the size of a float, right? So it's 8 bytes. So a 5.0 to the compiler says, perform this algorithm, not integer division. You got to use floating point division, which is a different algorithm. So that's our signal there. Otherwise, what it will do is just do integer division, which is simpler, hugely faster. Okay, take the result and throw away the fractional part, and then convert that to a float, right? So it's stupid, isn't it? Because it's taken the 1.5, thrown away the 0.5, turned it into 1 because I thought it was only interested in integers, and then look at the left-hand side, and left-hand side of the equals has a double or float. And so, oh, this whatever I calculated is being assigned to a float. So I can't just say 1 integer. I got to say 1.0 and then turn that 1 into a fraction and then give it to the mean, right? So it's actually calculated the fraction, thrown away the fractional part, and then looked at the left-hand side and said, oh, that's a float. So tack on a dummy fraction, okay? And that's what's going on. And that's why we say, even before you look at the left-hand side, right, and know that it's a floating point number, just use floating point arithmetic. And this, I think this syntax also is used in many languages, at least in Java. Yeah, you have to signal to the compiler. This is a signal. Yeah, this is a signal. The signal to the compiler or the interpreter that you, or the byte compiler that says you are using floating point algorithms, not that, because that goes back a long time in computer science history, right? The distinction between integer space and floating point space. I think we went over this before in class too, right? Because integer calculations are floating point calculations are a new family of animals altogether, right? This is a huge order of complexity. More, if you can do things in integer space, just stay in integer space. Because many times, if you think about it, right? And it's you can bring this power to bear on your own algorithms out there. Because if you think about it, if you're using a floating point number, in your calculations, right? And you know the range of the floating point number, and you know that, you know, even though I'm working with floats, I'm only interested in 3 decimal digits of precision, right? Now, how many times have we used applications in which we are using floating point numbers, and we know that, you know, the biggest number you can deal with is, I don't know, the number goes from minus 5,000 to plus 5,000, right? Or minus 10,000 to, it's small, right? If you look at a double precision number, it is huge, right? But, you know, but what we're interested in is only minus 10K to plus 10K. It is a sliver of a hair. And we're saying we're going to design algorithms that work in double precision space when we're not even interested in the whole universe. I'm not interested in there's a movie, I think a famous movie, where it says, you know, I don't work in the world, I work in New York, right? So I'm only going to report on New York, not in the whole world, or something like that. There's some famous line in some movie, someone remarked to me. Like that, you know, so here, take a double precision problem that people have been working on, right? So out there, right? So when you start working, you find some problem that people have been using double precision algorithms to work on, and very time consuming, right? And look at the range, the active range, right? Is it like going only from negative 10K to plus 10K? And how many decimal places, right? So if, let's say it's going 3 decimal places, that's all you're interested in. So multiply every number by 1,000 and work in integer space. Right? And because it's only 10,000, the biggest number you're ever going to get, right, is going to be 10 times 10,000, which is like 10 million, which is, you know, which will fit in a long, right? Not even in a double long, it'll fit in a long. And you can work entirely in long space, you know, integer space, and no floating point calculations, and you can see, you profile your code, right? And say, right? And so what's going on there is that, you know, that is the ultimate trade-off, right? If you know data representation and you bring that to bear, you say, well, you know, this space, this I have this many bits, but I'm only interested in this many bits. Why should I be doing calculations on these bits, right? So what I do is basically just mask everything and work only on the 5 bits that I'm interested in, right? So that way you can just speed up all your algorithms. Yeah, I don't know, right? So I think I gave you an example one time. We actually managed to get incredible wins using that kind of logic, right? Back at us, all right, at one time. Anyway, so what we're going with that. So yeah, you know, at the end of the day, we're just coming back to this question, right? So divide by 5 points as, you know, use floating point operations, not integer operations. Yeah. So all right. So now you say mean equals, you know, float mean equals, and then what is it? Find mean, and just give it 5 numbers, 5 integers, and then what we'll do is now look at a different way of calculating the average. Okay, we will pass the average in by so say, all right, type float mean equals float mean equals. Yeah, just give it 5 numbers, right? Just give it 5 numbers. Find underscore mean. Yeah, and then give it, you know, 1, 2, 3, 4, 5. I think, what is it? 1, 2, 3, 4, 2.5. Is 2.5 1, 2, 3, 4?
Oh, 1, 2, 3, 4, 5.
5 times 5 plus 1 over 2. $15 over 2, 7.5. Sorry, yeah, 7. Right. So and then yeah, this will print 7.5. Right. Now we'll try and do this in another way. Did it print 7.5? Why didn't it print 7.5?
I didn't print it out yet.
Oh, but you ran A dot out? I thought you ran A dot out.
I got 3.
You got 3? Yeah. Oh yeah, of course. Divide by 5. I divided by 2, right? So 15 divided by 5 is 3. Yeah, the 3. I divided by 2. Hey, how do we get fractional number there? Yeah, I have an even numbers, right? So I think 1, 2, 3, 4. That will say 10 divided by 4, right?
1, 2, 3, 4.
Yeah. Oh, but you can't do that. You get rid of the parameter e. 4. I don't know. Somehow fix that however you want, right? So we want a fractional number there somehow. Is everybody following along? We're just playing with different ways. And if you guys want to do different, you know, just chime in. You know, I'm just calling things that I like to get through.
All right.
right? Yeah. Okay, so you're getting 2. What is it? You're getting -2. What's no? It's
Yes,
hey,
2.5.
drag the. Is your window really tiny, or I can?
I think it's because like I expanded the or I increased the font size, so it just got
No,
smaller.
the total, the bigger window, because my gallery here is bigger. So I'm wondering if your Chrome window itself is. Oh, that's the max you got. All right.
That's the max.
All right. So maybe half will do. All right. So that's good. Now, what we want to do is, let's say we didn't want that function to calculate the value of. Calculate the mean and return it. See, in this case, it's returning it, right? We're going to look at one other way in which you can get results from a function. It's very common. This is called calling by reference. Okay, here. Okay, so now instead of so just say after in main after float main, just say semicolon.
Where?
No, after main, yeah. Put the line back. Control Z out of it. Control Z one more time. Okay, after float main, say semicolon. No, after float main itself. After float main itself.
Oh, float mean. Okay.
Oh, no, I'm saying main. I mean mean. Oh, we should have called AVG, average, right? Right. After float mean, just say semicolon. After float mean, say so. I'm so sorry. It's just confused the hell out of you.
Semicolon.
Not there. Oh, I'm sorry. On line 18, on line 8, on line 17. Go after the word mean, after mean.
Oh, okay.
Yeah. Well, I didn't want the whole thing deleted because we're going to have to type it in anyway, right? All right. So put a semicolon after float mean. We're just declaring the floating point mean. Yeah. Okay. And then hit enter. Hit enter. One more time. So that now we're going to calculate the mean in a completely different way. Now say, get rid of the equals and everything. You just say call the function find mean. Yeah. All right. And go to the end of the function after the 4, comma, after the 4. No, there on the same line. After the 4. So here's a new way, right? We're trying to keep things as simple as possible so that we're only exposing what exactly passing by reference means. Okay. So this is very important. Right. So 4, comma, and say mean, right? 4, comma. No, after the 4, say comma.
Oh, okay.
So we're going to pass mean as a 5th parameter. All right. So here's the funny thing, right? So we're calculating the mean. Yes, Chiangi?
I'm sorry for interrupt. I keep getting 2 instead of 2.5, even if I put the 4 point in the calculation.
You're getting 2?
Yeah.
Are you returning an int instead of a float?
Oh.
Are you assigning it? Yeah. Okay. All right. Cool. No, it's very common. It's a very common error. Okay. All right. Now here, it's probably going to say that mean is uninitialized or something. Mouse over.
I think it's too many arguments
too many, because we haven't redefined the other one yet. So now go back to your float, the function, and now make it return void. So it's not going to return anything. Yet it's going to calculate the mean. It's going to calculate the mean, but it's not returning anything. So how can you get the mean? So what we're going to do is get the mean in as the 5th parameter. Right. So after the int d on line 8, yeah, I say comma, and I say float mean. Right. Now the mean is coming in as a 5th parameter. However, this is wrong. Okay. This is wrong because if we calculated the mean and said it's mean, we're getting mean as a copy of that mean. What we want to say is, I'm giving you a 5th parameter, but this 5th guy is special, not like the first 4 that I gave you. The 5th guy is what is called a reference, meaning I don't want you to give copies of each of these parameters. Well, I want you to give copies of the first 4 parameters, but the 5th guy, don't give a copy of that guy. Pass that guy as is. So what we're going to do is float space, and then before the word mean, say ampersand. Okay, and this is the only syntax you really got to get. Well, this and the star for dereferencing. This is something you got to get used to, and you will get used to. Right? This is called passing by reference, a function which takes a parameter in which in the declaration the parameter name has an ampersand before it, means that you have not received in this function. You have not received a copy of that value. You have received the original thing itself. Does this make sense? The implications of this are actually quite staggering, because later on, you may be processing an entire movie, right? You have an object, which is an entire movie, right? And you pass it to a function. And that, that function does various AI things and says, okay, you got to do this particular thing in that movie in order to, right? So it's going to do these calculations, and you can afford to pass the whole movie by copy, right? It's like several gigabytes, and it's going to copy several gigabytes, right? So you got to pass the original. However, when you pass the original, you also got to be careful, because anytime you pass the original, you're at risk, right? Inside of main has got control over mean, right? Nobody can touch mean. And if it passes mean, if it passes that value to another function, right, it only gets a copy, it doesn't get the original. So main is self-contained and happy. However, the moment main starts passing things by reference, not by value, right? By value and by copy, right? It's the same, right? As soon as main starts passing things by reference, it needs to be like super careful, right? It needs to, everything that goes out, it needs to be, right? So it'll say that, what you can say before the word float, you say const, right? Const. Yeah.
Isn't that kind of like using global variables?
Sorry?
Isn't that kind of like using global variables?
It is. No, it's not like using global means it's visible everywhere. It's like, if I want to talk to you, right? So I just paint the entire C++ class on a banner on 101. Okay. So
Professor, when we use an ampersand, so basically whenever we do this variable in this function reflects in the main, right?
Yeah, whatever you do there is changing something in main. But okay, whatever you do to A, B, C, and D is not changing something in main.
Because we're not using ampersand,
you do to the
right?
ampersand guys is changing something somewhere else. So that is a huge implication, right? Now, but if I pass an entire movie to some function and say, just count the number of frames in which this actor appears, right? And all said and done, that function may be written by, outsourced to someone, right? Maybe it's outsourced to Amazon or somewhere out there that can run some machine learning algorithm and do these things, right? I'm not doing that. And but how can I trust? How can I trust some third party who said they'll write a function in a cloud to do something on a big object that I have, and I can't afford to make a copy of that object and give it to that person. That person has written the function. So I'm going to pass it by reference to them. But this is a really precious thing, right? I can't pass a reference to something that's really precious to some random person out there who promises to look at this. So I got to say to that person, I will only pass this to you if you treat this as read only, meaning you will read it. So you can read it, but you promise not to touch it, right? You can't go and change things in it. So then you say in the function signature, you say, I take this by reference, but it's going to be a const. I promise not to touch it. So inside of the function, you assign something to main. Actually const value. Oh, I'm sorry. In this case, it can't afford to be const, right? You got to calculate the value and put it in there. So in this case, especially, so I use the word const as an example when we're talking about movies and then got confused here, right? So yeah, so here we're saying, I'm giving you a container that contains mean, right? So when you calculate and change the value of mean, I will automatically know what the mean is, right? So here, you can actually say, in fact, does GDB, does this have a debugger? It'll be really cool, right? So here, what you're going to say is it takes, float mean equals, right? So right there, you say float mean after on line 16, before
line 16.
Yeah, on line 16. You don't say float anymore because mean has been given to you as a parameter. You get rid of the float thing, right? Now mean, and you got an extra space there. Okay, so mean equals.
Then equals this, right?
Right there. Is it? Oh, I'm so sorry, Chris. I thought you were in that function, not here. Put back the float.
Oh, okay.
Yeah. Put back the float in front of mean. Up there. You get rid of the float there. Get rid of the float, the word float there, and the extra space. Yeah. Now you're actually going to assign to that mean. Okay. Now mean equals A plus. That is it. Right now, the next line, just say return. Just say return. What we want to do is, can we? Okay, you can do this in Xcode maybe, because or other debuggers, or even here, if we know the exact location where this main stores that variable mean, you can see that in the debugger, even though you're in some other function, you're stepping through these things. As soon as the value of mean changes in that function, main's copy would also immediately reflect the change, right? So any damage accrued by that value will be instantly reflected here. So you can, I wonder if there's any way to demonstrate that, but you can find out. Anyway, so this is the way, this is the other way in which you can calculate the mean of these numbers. Right now, here's a more, let's make this more interesting. Okay, instead of giving a fixed number of numbers, let's pass it a vector of integers. Okay, so get rid of, so find mean, get rid of all of those, and say vector of integers in a square int, right? And again, because it's going to be a vector, it could be like 1 billion integers. I don't want to give a copy of 1 billion integers in main to you. So here is where I'm going to use the word const. Okay. So yeah. And then before the nums, you're going to say ampersand. Now we're going to pass nums as a reference to the actual vector, not the vector itself. Right? Not a copy of it. It's going to be a reference to the actual vector. However, I don't want you to go and change, go in and change the vector. So I'm going to put a const in front of the vector, right? Put a word const. That means that I'm going to give you the original vector that I have. Okay, you're free to look into the vector and read all the values, but don't try to change anything in it, right? If you change anything in it, I'm not going to give you the original vector. So that's really what you're saying. That saves you from the bother of having, because you see a lot of programmers, right? They see vectors, they see hash tables, they just use them willy-nilly, bam, 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 bam. They don't even know, right? And then you say, it'll get the job done. It'll get, it'll get the job done even for from modern computers, even with a vector of 1 million integers. You can pass, bam, by copy, it'll get it done. But think about what a tremendous waste, right? What a tremendous waste to pass 1 million integers, right? It'll get done, and eventually they'll say, well, let's cost it into the capital or expenses and all these things. Yeah, it'll get paid for. This is a carbon waste, burned for waste, essentially, isn't it? So I think when you know these things, right? That person is not going to mess around with the vector. So even if it's 1,000, even if it's a 5-element vector, right? If they're not going to mess with it, I'm going to pass it by reference, right? I'm not going to give them a copy. So I think that kind of mindset is, I think it's a mindset of economy, right? No matter what kind of program you write, the program could be the most grandiose program. Eventually, you'll get into the mindset, I think, as good programmers, the mindset of economy for good. The reason why the mindset of economy works is that it keeps everything as simple as possible. Right. So if you're not in the mindset of economy, then we can pack rats and start accumulating assets and things like that. And everywhere, there's too many things occupying our mind all the time. Right. So the mindset of economy, so like LDL, right? LDL is the low dependency lifestyle, right? So in programming, keep all the coupling low. Always focus on only the module that you're looking at, and then sacrifice all the power that comes for free. If the extra power you get is an encumbrance rather than a benefit to you, you should say, I don't want that power. I'll give up all that power, because if that extra power is an encumbrance, when I need that extra power, I'll take it. Right? I'll take a more sophisticated. I won't use a stack when I actually need an array. Right? Or maybe I want an array in which I want to have access to both ends, not just the front end. Right? Then I'll use a queue, right, instead of a stack. So you can take a fully powerful, all powerful data structure like an array, and you can disguise it. You can mask off various portions of it so that you transform it into a particular data structure that is suitable for the thing you need, so that you don't have to worry about things that are masked off. So that's the idea behind masking. Masking is not say, oh, I'm going to give up all the power, right? So, and say, oh, I don't have the array anymore. I can't do anything I want. So I've given up all the power. No, you've given up all the headache, right? So you're saying all these things I don't want. So I'll only need to look at these 2 ends. So only everything else can be automated. So that way you can basically just. All right. So this way, if you run this now, you'll get exactly the same result, right? So we haven't completed it. So here, so now you can Chris or anyone else can walk through Chris through. All we need to do now is loop through the vector, calculate the total, divide by the size of the vector. That is a mean, right? And you take that and put it in the mean. Now, right? So, and yeah, I think this is going to be good that we put it in mean. It's actually, this is going to be really good because now it'll also give us an opportunity to go back and change the signature so it's not void, it's a Boolean, right? And why would this even return a Boolean? Why? So you can think about it, right? So why would we even think about making this function, which is going to calculate the mean of the numbers in a vector? Why would it return a Boolean? It's going to calculate the mean and put it in mean, but what reason could there be, right? So we'll come up with a reason. I think it'll be a good reason too. All right. So for int I equals 0, I equals nums dot size. Yeah. I plus mean plus equals nums of I. Okay. At the end, you want to where's?
I think it's getting a problem because it's adding a float and an integer.
No. Get rid of the word float mean equals 0, right? You just say mean equals 0 because mean has been given to you, right? Mean has been given.
Oh, okay. Yeah, true.
Yeah. Enter there. Enter there. Not there. At the very beginning, before you start adding to mean, you say mean equals 0. No, before the for loop, just say mean equals 0, and then you start adding to mean each of the numbers, and before you return, you got to divide mean, right? Why is mean underlined? Why is mean underlined? Oh, because it's const. Yeah, it shouldn't be const. So mean shouldn't be const. Only the vector should be const. Yeah. Yes or no? Because you're going to assign to mean, but you can't assign to vector. Thank you. All right, enter. Okay, now, so does everybody follow what Chris has written so far?
Yeah.
Everybody? Hey, anybody have any questions? I got everybody. Okay, Rishabh, are you good? I'm saying there's so many people here I can ask. Okay, Rishabh, are you good?
Wait, so is the ampersand like basically like making like a copy of that?
No, ampersand is the opposite. If you don't have the ampersand, it's going to make a copy. If you have the ampersand, it's going to pass the actual one.
Okay. Yeah? Sounds good.
Okay, David, you good? Howie-An, you good?
Yeah.
Okay, Chris wrote it, obviously. Mark, you good? Chanji? Jingheng? Thumbs up or down? I can only see half your face, Jingheng.
Can you see me?
You good? Good? Everything okay? Turkey,
sure.
okay? Elizabeth?
Okay.
I still have problem with like constant and the ampersand. So
you right? Right.
Yeah. Like what the different one make if you don't put it.
Constant basically means this parameter cannot touch that, right? Meaning it can read it, but it can't write to it. That's what const means.
So constant cannot be changed, right?
Const cannot be changed.
Oh, Professor, so why would we use constant and the ampersand at the same time?
Right. Sometimes we want to pass an object to a function, right? In this case, we're passing a vector to a function. Yes? We're passing this entire vector and saying calculate the value, the mean of this vector. The entire vector is being passed, but we don't want that person to, well, two things, right? This vector might be very, very big. Might be a vector of 1 billion integers, right? Or trillion integers. I can't afford to make a copy of the vector and give it to that person. Because especially if that person is not going to change anything, right? It's a waste to make a copy. So I want to pass the actual vector and say, here is the actual vector. Here is my home, go and paint it, right? So I'm going to pass the actual vector.
So just making it more efficient?
Yeah, incredibly more, right? So sometimes you want to pass the actual object. For if you want your house to be painted, you want to pass your actual house to the painter and say, right, here is a model of my home painted this way, right? Then I'll paint it like that. No, you got to pass the actual thing. So ampersand says pass the actual thing. If you don't say ampersand, the default in C++ is always to take a copy of the thing being passed, unless the thing is a native array, okay? The only thing that gets passed by reference automatically is a native array. We haven't spent a great deal of time talking about native arrays, so I'll just leave you guys to read up about it, because most of the time we're going to end up using vectors and so on. Native arrays is, I think at this point in C++ is almost getting to the point of assembly versus C++, right? Because it's there, you can do it, but you don't get anything more by using native arrays. that you don't by using vectors. But vectors come with so much more nice things, right? So if you want to go the absolute fine-grained last mile, you can still go to native arrays. Yeah, let's not even talk about native arrays, and because then we have to talk about why native arrays are being passed by reference, by default. In C++, everything gets passed by copy. Exactly the opposite as Java, right? In a language like Java, I'm pretty sure it is, right? Everything is passed as everything is a pointer. Everything is an object, right? In Java, everything derives from an object, right? And so everything is a pointer. So, we haven't even started talking about pointers. Yeah, so in C++ anyway, everything is, it will get passed by copy. If you don't want it to be passed by copy, you have to say ampersand. If you don't say ampersand, it's going to be copied, right? And sometimes you don't want it to be copied if it's a big item. But what do? If you do, if it's a big item and you pass it and it's going to be copied, if it's not going to be copied, you're passing the actual or original item and you don't want the other person to type, to mess with it, then you'll only select people that promise not to mess with it, right? They'll look at the blueprint and say, for example, right? So you give them a plan of for painting your home, right? That room is in orange, this room is in green, and so on and so forth, right? They can look at the blueprint, but they can't change the blueprint, right? They can say, oh my gosh, you painted the room purple. Oh my gosh, right, let's change the blueprint now to purple, right? So they can't do that. Okay, so the blueprint is read only. So you pass the blueprint as a parameter, but also mark it as const, right? So it comes to the painter. They can refer to it, you can read it, but they can't change it. However, you pass the house by reference, but it's not marked as const, right? Because that is also something you got to pass the actual thing, but they got to change it according to the blueprint. So here's a great example, right? So I think that's a great example where you can do this. So that's basically it. So Elizabeth, who else? Hey, Yenyu, are you clear so far on everything? All right, Ray, you good?
Yeah. So what thing are we passing to the nums here? So we're not leaving and copying. We're passing the real thing, right? But what specific thing we're passing?
Oh yeah, I'm sorry. Ray's asking. Oh, we haven't actually gone in main. Go. Yeah, let's finish this up. All right, go to main. Let's get rid of vector. Yeah, say vector and I don't know. Yeah, nums. Call it nums, right? No, you can just say nums and say open parentheses. Let's say 1,000 numbers in there, right? You want to keep it 100? I don't know. Up to you guys, right? Right, on the next line, use a for loop to assign 1,000 random numbers to each of the elements in the vector. So say for int I plus 0, I less than nums.size. This is a standard pattern we'll pretty much get used to, typing very often in C++. And rand. No, percent 1,000 will make sure that the numbers are between 0 and 1,000. And then at the very top of main, before the for loop. Actually, you know what? Let's even call it at the very top of the line, at main itself, because these days when we're using objects for declarations, who knows? The constructor might invoke rand, right? So we want to make sure srand is called even before the very first call, right? So at the very beginning, after the brace itself, just say srand, open parentheses, time, 0L within parentheses.
0L?
Yeah, capital L. Yeah.
Capital L.
Doesn't matter. All right, semicolon. All right, enter. All right. You can put a comment there on that line saying this will make sure the rand on the same line as srand is better, right? Yeah, say this will make sure rand will return new randoms every time. Oh, you done it already?
Yes.
Okay, now all you need to do is pass nums as a parameter to your find main method, and mean also as a, oh, you do that. All right, so see, I mean, all right. So this will actually,
I think you have an extra key there.
Right? Hey, just use 10 random numbers, then you can also print out the 10 numbers, and we can verify it, right? In fact, change that 1,000 into into a magic, into a uppercase, all uppercase size, right? Or
Wait,
num
change the what?
yeah, change that into NUM in capitals, and above float mean will say const int num equals 10.
Const num.
Int. It's got to be an int.
But I couldn't hear you. What would you say?
A const int num NUM in uppercase, or size or what? A num size, num underscore size, num size
equals 10.
Yeah. Enter. Oh no, actually, yeah. Yeah, num size there. Thank you. Yeah. And then make the numbers also between 0 and 100 maybe, or 0 and 10. I don't know. Between numbers rand percent 1000, is it rand percent 100, rand percent 10, or something like that?
Right here?
Yeah, make that rand percent 10. So it's a random number between 0 and 10. Okay, now after you calculate the mean, also have a for loop and print out the numbers in the vector where, and the mean equals also, you can tag the next line, right? Yeah.
So that would be
nums
num
size
as well, right?
Nums size, and then nums plus plus. Yeah, and then nums plus plus. Oh, I plus plus, I'm sorry, I plus plus.
I plus plus, and then.
Hey, does anybody else want to go, or I'm pretty sure Chris will be happy to. Right, we're just coding, okay? So anybody wants to go, just let us know. Yeah, see how nums is a open code. Always tag it. I think it's easier when you debug it, right? So nums square bracket, and then after outside the code you say I, and then close the thing. Yeah, equals. Yeah, okay. Yeah, that's fine. And endl. Oh, I'm sorry. Well, you had it right. Nums of I and endl. Okay, and then above the for loop, you can say the numbers in the vector where or something like that, right? Input numbers equals or something like that. Yeah, see how input numbers equals.
What would you say?
Something, tag it some, say within quotes, input vector equals. Equal sign, and then new line. And then get rid of the space after the equals. Yeah, it's strange, isn't it? Because here it looks very asymmetric, but then still it doesn't make any sense. All right, so and then you say tag the mean line, right? On line 43, say mean equals mean. So yeah, now we should be able to run it. It'll give us the vector and also print the mean, and then we'll try and do it in a different way. Right? Mean, yeah, okay. If you run it, now you can increase the size of the console. Yeah, I think that's fine. Okay, all right. So input vector, it gives you those 7 numbers, 10 numbers there, and then the mean.
Yeah.
Here you can calculate it. I'm very. It's got to be somewhere around 5, right? I think it's got to be. Yeah, it's a central limit theorem, right? So the mean of the 10 uniformly distributed numbers is going to be around 5, right? Because the Gaussian will be centered at 5, right? That's the. In statistics, we learned this thing called the central limit theorem. It's incredible, isn't it? No matter what the underlying distribution, if you just add up random numbers from that distribution, you always get a random that's normally distributed around the mean of that distribution. So here you'd expect it to be 5 most of the time, then 6 this time, sometimes 4, sometimes equal likelihood, right? And the extreme numbers less likely. All right, so you can run it again. You'll see something around 5, 4, 5, 6, right? So run again, up arrow, yeah. Oh, you don't have to compile each time. You just say a.out. Oh, you actually get 5.2. Oh, that's right. We're returning him. Yeah. So in fact, if you run that like a million times and then plot the values, you'll actually see the bell curve, right? It'll be peaked at the bell curve will have a mean at 5. All right, 5.1, 5, yeah, it'll just go like that, right? And 0 and 9 will be very unlikely, right? Because in order to get 9, you got to get 9 every single one of the 10 times, right? Because you're going to divide by 10 at the end. So it's very unlikely to get the same number every single time. Or low numbers every single time. Anyway, you can run this many times. Now, what we can do is go back to the code. So does everybody understand what we've done so far? Okay. Now, what we can do is, why does this function that we wrote at the top, the function at the top, it returns a void, right? But obviously, it does not have to return a void. Anytime you return a void, you can ask yourself, can it return something more meaningful than void? Right? We shouldn't make it return something meaningless. But in this case, it actually happens that it can return something meaningful. Because what happens if the input vector was empty? Chanyi, you have a question?
Yes, after running this program, I got a warning on the mean plus equals to nums I. It says thread, bad access.
Oh, it says bad access?
Yeah.
In Xcode, I see. Nums, what does your loop look like? I equals 0, I less than nums dot size?
Yes.
Did you want to take over so we could see how it looks?
Yeah, we can. Yeah, if you want to take over, we can look at your screen. Where are you passing main? Go to your main. Go to your main. Where's your nums? Wait. Nums, comma, mean. Find mean. You're calling find mean with nums and mean, and nums is an array of num size integers. That's good. And that's all fine. And so let's go back to your find mean. Find mean. All right. So mean equals 0, I equals 0, I is less than nums dot size I plus plus. And it says bad access here. Okay, is this GDB?
It's Xcode.
Oh, it's Xcode. Great. Okay. All right. Excellent. Just go to line 10. Here, guys. Here's a great way to debug your code. Okay, and you can. All right. So click on the left margin next to 18. Next to 18.
Next to 18.
Left margin.
Oh, sorry.
Yeah, it's okay. You should see a blue dot. You should see a blue dot there.
So like mouse over the number 18. Yeah, right there. A little bit.
Click that. No, not a mouse over the 18. Go to the margin under margin to the left of 18. To the left of 18. Right. Click there. You got to create what is called a breakpoint. I just click on right click on 18. Right click on 18. Right click. Okay, set breakpoint. No. Right click and set breakpoint. Oh, it says it already has a breakpoint.
Edit breakpoint.
No, I can't see the breakpoint. Why can't? Maybe I should just increase the size of this font. Hang on, just 1 sec, okay, Chanyi. I'm just really having to peer. All right. Okay, some of you are going to disappear off screen now. Okay. All right. Okay. Now, can you move your mouse a little bit? No, make that rectangle go away. Click somewhere. Oh yes, of course. You have a breakpoint, right? So you see that blue tab? I couldn't see. I thought it was different. It's got that arrow. It's got that thing there. That blue tab on that line says it is what is called, debugger calls a breakpoint. That means this is incredible, isn't it? This is fantastic, right? You have the power now to run the program step by step in C++ and look at what's going on, right? Every single statement you can run one at a time. All right. So here now let's actually go to main. Go to main. All right. On that srand line, click just like that before. Click on Click on 27 on the left hand side in the margin. Yeah, there you go. All right, good. So you see that blue thing, tab. Okay, it's called a breakpoint. If you run the program now, click the play button right to the next to the play button. Yeah. Okay. No, click the button. Oh, build success. It's a bit slow. All right. Okay. All right. Great. You see that now? It has now started running your program, and it is waiting on line 27, waiting for your command to proceed to the very next line. It's just hanging there. It's not run it yet. Okay. Now, in order to get to the next line, all you need to say is in this window called LLDB, right? You can, in fact, drive it in ASCII mode. Let's not do it, right? On to the left, you see all these icons. To the left of that, above the window on LLDB, in the ribbon, in the ribbon above LLDB, right? You see the play button, the pause button, and further down, down, further, in the lower half of the screen here, where you see LLDB. Go to where you say further down, even more. There. Okay, all right, up. All right, you see those buttons?
Yes. Okay,
so they are your debugger buttons, right? Now, the second button from the third button from the left, where you did jumping over the rectangle. Can you see the jumping over the rectangle? Okay, that says step over that statement. Okay, don't go into the statement, but step over it, meaning execute the statement and come back into main. Okay, now click that. The green bar moves to the next line. It says now I've executed the SRAND line. Okay, now keep clicking that next, keep clicking that, you'll see that advance one step at a time, one line at a time you're executing, right? Keep going. Go, yeah. Right, now you see the for statement is executing one, and the value of I, if you look at the value of I in the lower, just below the button, just below the button where you're clicking, hang on, one sec, right? You see I equals int 4, you see that? Further down,
yeah.
I, that's the value of I. Right, num size equals 10. All your variables are basically displayed right here. And you can click that button again, you'll see the value of I change. Click the button again, you'll see the value of I change. Click.
Oh yeah, change to 5.
Right, so you can actually follow your program one step at a time. You can see what's going on, and you can see exactly where the bug is in most of your programs. Right, now, so now we know, suppose you have a for loop with 1 million entries in there, right? You don't want to be sitting there clicking it 1 million times, yes? Okay, so what you want to do is basically go to line 38 really quickly. Yes?
30.
No, wait. Yeah, line 38. You want to get out of the for loop and go to line 38 really quickly. Yes?
Yes.
Okay, so right click on line, right click on line 38. Right click, yeah, and say continue to this line.
Continue to here.
Continue to here. That means it'll just zip through the for loop now. When you're happy with the for loop, you know the problem is not with the for loop. You don't have to go through the remaining million items. You can just say zip through, right? You go to this line now. Everybody okay with this? Now, Chanye is doing this in Xcode, but exactly the very same thing can be done in any debugger you have, whether it's VS Code or GDB or whether it's Chrome, right? Or it's a Replete Online. All debuggers have exactly the same functionality. The buttons might look very slightly different. Even the buttons look very similar, right? Maybe it's placed in a different place, right? VS Code might have it here. I don't know, right? Even the buttons look very similar. So as long as you know what these buttons do and where they are in Xcode or VS Code, you're good, okay? This is exactly what you can do. Is everybody happy with this? Because this is like the most important skill you can ever pick up as a programmer. Is basically being able to debug, because what happens is that when we start programming in bigger scale, there is a level to which it is easy for us to mentally simulate things, right? Right, more bigger than that, we would rather have the machine do these things and go to the next stage, right? Because our mind is running faster than the computer, right? Because our mind is simulating things at a higher scale. It's doing things much faster than a computer. People always say computers are faster, right? No, our mind is actually doing things at a faster scale. It needs things to happen faster. So it can tell the compiler or the computer, I need to do things really fast. Go ahead and do this for me, right? So the computer does things fast in order to keep up with the mind. People always have this inverted idea, saying computers are faster than the human mind. No, today's computers are slower. No matter how fast it is, the computer is used to help our mind skip over things to get to our goal faster. Yes? So if you look at it from that perspective, we're telling the debugger, I'm happy with that for loop, right? I know the problem is not there. Zip through it, get to this place. This is where I think the problem is. So now you have the power, the fine-grained power to drive this chariot called your computer at any speed you want. You can make it go step by step. You know, you can make the horses dance all the way to the palace, or you can make them gallop. Does that make sense? So you have the system going at mind speed, essentially.
I see.
Right. Okay. So now we want to find your bug, right? Now at this point, we know the bug, you know, your exception happened inside of find mean, right? So you don't want to say to the computer, okay, well, zip through find mean through, go to the next place, right? You don't. So you want to go step in. You want to step into, yes, you want to go into find mean, yes, and see what's going on. So here you would right click, okay? You can see anywhere on the green part, right? Wait, don't select anything. Don't select anything, right? What you want to do is step into the function. Is it there at all? Well, okay. Well, we'll use the button, right? Next to that jump over button, you see that a button with an arrow down arrow. No, not there. The buttons, all the buttons you clicked before.
Here, this one.
Okay, mouse over. It says step into.
Step into.
Yeah. So you want to go into the function now, not step over. You want to go into. Click that. Now you're in the function. You can do exactly the same thing, step by step, right? Step by step. Execute. One. Yeah. Go. Step over.
Step over.
Yeah, step over. This is a great exercise. You know, Chanyi is so lucky to have this opportunity to run the debugger here, right? Because you'd never have the opportunity to go and, you know, you can go to STEM Center and say, teach me to use the debugger. What does it say? Low battery on my iPad. Forgot to charge it. Can you say anyway? So right, so it's very hard. You can go to the STEM Center, but even then, you know, STEM Center, they tell you how to use debugger, but people don't. They won't. You have to be forced. You have to be forced to use the debugger sometimes, right? But once you use it, it's very useful, right? Same thing with even the questing side. You know, the memory leakage report is actually very useful, right? But many times people have to be forced to read the memory. But you know, in CS2A, don't read it, right? Because it's more confusing. But CS2B and 2C, it has a lot of information, right? People just don't read it because they get spoiled and don't read it. But it has a lot of useful information in it, right? Okay, all right, step, loop through it now. Now here, you don't want to zip through the loop, right? Because we know the error happened inside the loop, yes? So don't zip through the loop. And so step through it, all of a sudden, and look at the value of I, right? You have to look at the value of I, look at the value of nums, right? Num size is 10, good, all right? Mean is also being calculated, right? 1 sec, all right, stop 1 sec. Mean is a reference, isn't it? It is not the actual value. It is the box that contains the actual value, yes? That is shown in the debugger by saying mean is, you see that ampersand there in black ink, in white ink on there? It says it's a reference. And it's a reference stored at the memory location. It doesn't show you the value of mean, it shows memory location. But it has this triangle, this open button on the left. There. You click that, it'll show you the value of mean too. That's the memory location where mean is stored, and this is the value, right? Now, if you step through the function, you'll see mean also change, right? Yeah, you step through the function. See, mean is being added. So the value is being added to mean. Oh, look, something happened. Why? No, go ahead. Your mean became wacky all of a sudden. Wait a sec. Why did your mean becomes
really big?
Why did it become so big?
It was 41, and then all of a sudden.
Yeah. So that's where the error is, isn't it? That's where the error is. Why did it become big all of a sudden is the question we're asking. Const, vect, int, nums, float. What does it mean? And where are you passing mean? Maybe you're passing double instead of float. Go down to your.
Because in the for loop, you're looking at one less than nums.
Oh, I'm so sorry. We're passing float address of mean. So I'm so sorry. There was a bug in the code, right? And we float address of mean. It's not a float anymore, right? We're actually passing. No, we are passing a float.
Oh, they're rendering on line 17. If
line 17 is I less than nums.
Because you got one less than, so you don't have a termination step.
Oh, I'm so sorry. Yeah, I'm so sorry. Thank you, Mark. It was just staring all of us in the face and we couldn't see it. Yeah, okay.
Line 17, yeah.
Yeah,
so
yeah,
line 17, instead of 1 less than, you want I less than.
The yellow color, the second yellow.
So
Second
after,
yellow, the
after
one.
I equals right there, and then change
Yeah,
that
it's
for
I.
I, and then see if that works.
Hey, some of you are really quiet today. I can't hear some of you at all. Isaiah is very quiet.
Yeah, that should be good. Yeah.
So I
Just
keep.
try to run it.
Wait, how can I begin?
Isaiah, are you here?
How can I start the loop again? Jump to definition.
Oh, I'm sorry. Yeah. Go ahead. If you.
How can I go to the for loop at the beginning of the for loop again? Because it's.
No, just so if you want to leave that function, or if you want to step through it, right? You want to step through it, just keep clicking that step over function.
Step.
Oh, but you changed the code, right? You changed the source code. You changed the source code, right? You changed the 1 into an I.
Oh, yeah.
Yeah, you might as well recompile it. So just hit the triangle, the play button again. Hit the top play button again. Right at the top, right at the top. Play. Yeah. Now you can also click that don't ask button again button next time it appears. Yeah, so you can hit, you can go to the function and hit continue there. No, don't set a breakpoint. Oh, you can remove the breakpoint. You can get rid of the, I'll show you. No, don't do that. Oh, all right, okay. Put the breakpoint again. I'll show you a really cool thing. Put it back again. Right, now drag it. No, click that and drag it to the left. You'll hear a nice sound effect. Right, now click the breakpoint and drag it to the left. Drag it out of the, yeah, there. No sound effect? No.
Wait.
All right. The other one also. Get rid of it. Get rid of it.
Okay.
In my old Xcode, it used to give the animation of a cloud and a poof sound every time I did that. All right. Okay. All right. Good. Yeah. Click that don't ask again button. Okay. All right. Cool.
Don't ask again.
Okay. Oh, they're at the bottom of the dialog. Don't worry about it now. All right. Okay. All right. Now you should be able to run it. Oh, you still get.
Sorry. Yeah.
How did I thought you changed it? Why?
I clicked the Command Z.
Oh, I see. Save it. Click the don't ask. Okay. Don't worry. Okay. All right. Cool. There you go.
Gotcha.
It all works.
Oh, sorry. This is.
Yeah. Okay.
Sorry.
All right. Oh, is it time, Elizabeth, already?
Oh yeah. I think for.
Oh my gosh, it's
for
10
the number.
Thank you for sticking around. But anyway, I think we did some cool stuff today, right? Because we got to know what passing by value and passing by reference was. And also, I think a very important skill is learning to use a debugger, right? Especially around this time, because you guys are getting stuck with quests. Next class, we'll do some recursion also, right? With like Turkey suggested, use or maybe not, I don't know, we'll see. But certainly before the end of class, before the end of the course. All right. So everybody okay with this so far? Anybody have any questions, or are we good? Because next class we'll try and do and take this to the next level, right? We'll
Can
try.
someone like share this code so that we can access it?
Yeah, I can do it.
Yeah, okay.
Professor, if we don't use constant and the ampersand, will it still run? Like,
no, why don't you try it? Yeah, will it still run is never a question you should ask in CS2A, right? Because it is now so cheap to find out yourself, right? So you can make the change, run it, and if it doesn't run, then you can ask.
Because in this case, we're not changing the variable, right? We're making system decide the random variable.
But you don't know if you change the ampersand to, you remove the ampersand, you'll get the right answer returned back and so on, right? So you should try it, and if it doesn't give you the expected output, you should ask in the forum, saying, hey, I tried to do this and it didn't do it. Can somebody explain? Yeah. Can you do that?
And yeah, sure, I'll do it.
Yeah.
And for the mean, why we're putting mean in the void function?
Why we're putting mean in the void function? Oh, why we're passing mean as a parameter, you mean?
Yeah.
Yeah, because it doesn't return anything now. So you have to pass it the value into which it can put the value. So you're passing mean as a parameter by reference, not by copy. It'll take a little while getting used to it. That's why you have to experiment and try and find out, right? Experiment and find out. And if it doesn't, if the result of an experiment doesn't agree with what you expect it to be, you should ask in the forums, okay? And say, hey, this is what I tried to do. This is what it did, but I expected something else. Why? Right?
So is it because void doesn't avoid a value,
No,
so
no,
we have to
yeah,
reference it?
Yeah, but you don't have to
parameter.
explain. You just have to say why. Can someone help me? Can say, or this is why I think, or you can say, this is what I think is happening. Can someone verify? Or do you agree? Right? Do you agree? Think so. You should ask, right? The best way to, learn programming is just by working with other programmers, getting comfortable working with other programmers. All right. If nobody has any other questions, I think we can call it a day and get back on Thursday. Yeah, Thursday morning. Yeah.
I have a quick question. How do we what would you suggest us to prepare for the exam, for the midterm?
Yeah, just get rid of all the questing homework before the week before, like by Sunday. And from Monday onwards, just review existing programs with the concepts, right? So branching statements. Then look at all the programs you've written in which you've used branching statements. Look at all the different ways in which you've used branching statements. Then look at some examples in the book, in lots of modules, online, where branching statements. You don't have to understand the whole program, right? Most of the time, many times I find that people get stuck when they're reviewing exam stuff, is they find a online program which uses a particular concept they need to use, right? And they try to understand the whole program. It's never going to work. Never going to, because people say, oh, until I understand the whole thing, I won't understand this part. That's not the case, right? If you're just trying to learn, how to find minimum spanning trees, and in this big graph, right? You just need to look at some small part of the code which does that. And programmers, through experience and many years, right, have learned to be modular, right? So, and good programmers are always very modular. So if you want to learn a particular something, right, they're not going to make you learn every damn thing, right? So even if you go to some big project, right, if you want to learn how Fortnite has been built, right, so this is game Fortnite, they're not going to make you learn entire Epic Studio, right, before you learn a particular thing about. So the code itself, you'll find all these good engineers structure the code such that if you want to learn a particular thing, you only need to go to that particular thing, right? And people who say, I cannot learn this until I learn the whole thing, they're doomed. They can't learn this little thing, right? So we got to be, and I think that is the risk, looking online. But you can look in, that's why I think I like Losef modules, right? So that's why I made them available, right? So if you look at Michael Losef's code, even though it might come from big chunks, he'll have these rectangular boxes, right? Rectangular boxes in which he'll only have like 10 lines of code. But the 10 lines of code itself won't run. It's part of some bigger program. But his discussion will be only about this 10 lines, right? So you can only look at the 10 lines and it's enough to understand the 10 lines. That's where the entire logic is concerned. And most of the textbooks also do that, right? But I like the Losef modules because in some of these come from bigger programs, right? So and which you will be writing, so you'll be fitting them in. So right? So yeah. So yeah, don't get lost. Don't get lost in the forest, and just look at the bit. And that's the best way to learn, right? So while loops, just look at the while loop parts of all the programs you've written. For loops, right? If statements, bit by bit, right? And data representation, be solid on it. I'm not going to be testing anybody on data representation, right? Explicitly. Right? Implicitly, of course, right? You may know, right? Why does this loop is using size t for less than 0? Those kinds of things will bite you, right? You'll find out on your own.
Thank you.
All righty. All right. Thank you very much. I'll see you guys on Thursday. All right. Bye-bye.
Professor.
Bye.
See you Thursday.